Hello and welcome to Nikolai's Genetics Lessons, and in this video I'm going to explain how to calculate inbreeding from a pedigree. Imagine that we have a pedigree as follows. So here we have female, so circle stands for female, and female would mate with one male and would have a daughter in this marriage, but also she would mate with another male, and in other marriage she may have a male. So this is going to be half brother, half sister. And imagine now that they would also marry or just mate and would have a daughter. So for example, daughter would be I, and this male would be A, and this female would be B, and this female would be C. Why I do not put any numbers for these two males? Because we are just interested when we calculate inbreeding by using a pedigree just in common ancestry. So for person I, so we can put arrow here that we calculate inbreeding for this person. We only interested in direct common ancestor, and for example this person here wouldn't be ancestor for this person here that we designate with C, but this person would be a common ancestor to C but wouldn't be common ancestor to A. So as you see, the only common ancestor here would be B. So how we are going to calculate inbreeding coefficient? And here is a formula: 1/2 raised n. And n here is the number of nodes. So imagine that we can connect all these people who would relate to each other by putting straight lines. So here is the first line, second line, third and fourth line. So our pathway would be as follows. So this is going to be I, A, B, C and I. And we can cross out I because we repeat it twice. So we have here 3 nodes. So this is going to be first node, this is going to be second, and this is going to be third. Now according to our formula we just have to use numbers, and this is going to be 1/2 raised 3, and the answer would be 1/8. So inbreeding of the I would be 1/8. Let's now consider different situation. So here we would have one female. Once again, that is going to be married to males, and in one marriage she would have female, in other marriage she also may have female. Both of them would marry two males, of course, and in this marriage they would have female, and in this marriage they would have male, and these two people would also marry and would have a male. So do you see a difference between these two pedigrees? So would you be able to calculate inbreeding in this situation? I recommend you to stop video here, try to solve this problem on your own. Now you have a formula, so I hope you would be able to do it, and I will proceed. So here we have slightly different situation. Once again we have one common ancestor here, and here is a common ancestor, so I would use red color. and for example, this person would be common ancestor to this, and of course to this and to this. But let's think about this person. Does this person share any of the genes with this person? So this daughter of these two people would have 50% of the genes of her mother, 50% of the genes of her father, but none of the genes of this unrelated person. So we just can cross out this person. And now let's consider this person, this female. She would have 50% of the genes of her mother, 50% of the genes of her father, but she wouldn't be related to this person. So we can cross out this person too. And of course, the same rules applies to other unrelated people. So direct relation would be here. So once again, we can build a direct path from people who would share their genes. So all these people would have some kind of relation. And relation here, I mean genetic relation. They would share some of their genes. So once again, we're using this rule in order to solve this problem. And now we just have to calculate our pathway. So for example, once again, this would be person I, and this is going to be A, B, C, D, and E. And our pathway would be I, A, B, C, D, E, and I. Once again, we just ignore these two, and we just calculate how many nodes we have here. 1, 2, 3, 4, and 5. So our calculations would be as follows. So this is going to be 1/2 raised 5. So the answer here would be 1/32. And now one more example. Imagine that we have a male here and female, and they would have two children that can be, for example, daughter and son, and they of course would also marry and would have daughter and son here. And this daughter and son also would marry and would have in their turn daughter here. So as you see, no matter what we put here, daughter here or daughter we can put here, the relation wouldn't be affected, because this two person would share genes equally of their father and mother. So this daughter would get 50% of the gene from the father side, 50% of the genes from the mother side, as long as her brother would get 50% of the genes from father side, 50% of the genes from the mother side, and as you understand, they would share 50% of their genes in common. So as you see, now situation is slightly different. So here we had, for example, in first example, two brother and sister who had a child, and inbreeding coefficient was 1/8. Here we had two half sisters that also would have their children. So here we have two half cousins that have common child. And in this situation, we have this person to whom both grandparents would be directly related. So we can cross out here this person who is not going to be related to this male to this son in this marriage. So we can cross out this female here that is not going to be related to this daughter of this marriage. And our direct pathway would be as follows. So here we can connect people who would share common ancestors, like this. But as you see, this is not the only one way how we can connect all these people, because the same person would be also related to his grandfather, and here is another pathway that is possible. So how this affect our calculations? And once again we are going to use the same formula, and let's put letters here. So once again this is going to be I, and this is going to be A, B, C, D, E, and F here. So let's write down the first pathway that I made with blue color. So this is going to be I, A, B, D, E, F, and I. So once again we just cross out I from both sides, and the second pathway that I made with red color would be I, A, B, C, E, F, and I. So once again we cross out. So let's now count how many nodes we have here. 1, 2, 3, 4, 5. So our calculation would be 1 over 32 for the blue pathway. So 1 over 32. And as for the red pathway, we also have 5 nodes. So this is going to be A, B, C, E, F. So once again 5 nodes, and this also gives us 1 over 32. But this time, because we have 2 pathways, we have to add them. So 1 over 32 plus 1 over 32. So we just can change colors here. So this is going to be red pathway, and this is blue pathway, would give us 1 over 16. So this is going to be our answer for the third example. This is our answer for the second example and for the first example. And as you see, here we have 2 common ancestors. We can make 2 pathways. That's why we use rule of addition here. Once again, here we have half brother, half sister, and here we have half first cousins, and in last example we have 2 full cousins, and here would be people who would be directly related to person I, and all of them would share genes between themselves. So A would be related to F and E and D and C. The same applies to every person in this circle, except that person C and person D wouldn't be directly related. They wouldn't share genes. They wouldn't have common ancestors. That's why we built 2 pathways, red and blue. And the direction of the pathway doesn't matter. You can build a pathway in this direction or in this direction. So it actually doesn't matter. What matters, you have carefully to calculate number of nodes and then use our formula. So this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any. And see you in the next video. Goodbye.